Hey everyone! By the end of this video, we hope to have given you a good understanding of the Pythagorean identity and how to use it. Alright, let's dive in. What is an identity in maths? Well, it's basically an equation that is always true for all values of the variables. You've probably dealt with some already. Let's have a look here. We've got our perfect squares and our difference of two squares. In this video, we're going to be focusing on the Pythagorean identity. Now let's have a look at where the Pythagorean identity comes from. We start with the unit circle, which is just a circle with its center at the origin with a radius of 1. That's why it's called a unit circle. It's a very important tool in trigonometry. What we're going to do with it is make a right angle triangle with the x-axis. To match the axes, we're going to call the base of this triangle x and the height of this triangle y. And we're going to call this angle with the x-axis theta. Let's blow this triangle up a little bit. And with this triangle, we're going to see where the identity comes from. Let's work from here. What we're trying to do is write x and y using theta. To do this, we can use a few trig ratios. So we know that sine theta is opposite over hypotenuse, which is y over 1, which is y. So we can replace y with sine theta. We're going to do the same with x. We know that cos theta equals adjacent over hypotenuse, which in this case we have x over 1, which is x. So we're going to replace x with cos theta. Now from here, we can see that using the Pythagorean theorem, a squared plus b squared equals c squared, we get sine squared theta plus cos squared theta equals 1. And this is where the Pythagorean identity comes from. So how do we use this identity? Well, at the most basic level, if we know sine theta, we can find cos theta, or vice versa. So let's have a look at an example. Find cos theta given that sine theta is 1/3. Let's start with our Pythagorean identity. Now, since we're trying to find cos theta, let's rearrange this for cos squared theta. Let's substitute 1/3 for sine theta to give us 1 take 1/3 all squared, which is 1 take 1/9. And we know that this equals 8/9. Now we need to square root both sides to get cos theta, not cos squared theta. So that means cos theta equals plus or minus root 8 or 9, which simplifies to plus or minus root 8 over 3, or plus or minus 2 root 2 over 3. So what we have found is that if sine theta equals 1/3, then cos theta can be positive or negative 2 root 2 on 3. In the next section, we're going to have a look at how we can take this identity even further. Now, what else can we do with the Pythagorean identity? It turns out that there are a few other versions we can make. So let's have a look at them. Starting with sine squared theta plus cos squared theta equals 1, we can divide both sides of the identity by sine squared theta. This gives us 1 plus cot squared theta equals cosec squared theta. Pretty cool. We're going to do the same thing again. This time, we're going to divide both sides of the identity by cos squared theta. And this gives us tan squared theta plus 1 equals sec squared theta. And these are both identities that you can use in trigonometry as well. As we near the end of this video, let's just mention some other applications. So we can use the Pythagorean identity in trig proofs. We can use them to solve trig equations. We can use them to solve problems in geometry, just to name a few. That is the end of this video. We hope that you have got a better understanding of the Pythagorean identity and how to use it. If there's any other topic that you'd like us to make a video about, drop a comment, let us know. Thank you so much for watching. See you next time.